In the last few weeks, the mystery surrounding the interstellar object known as 3I, Atlas, has taken a sharp and fascinating turn. New data released by Harvard astronomer Avi Loeb has reignited debates that had briefly quieted after its perihelion passage in late October 2025. What seemed like a fading cosmic enigma is once again at the center of attention, not because of speculation, but because of new, measurable evidence. Avi Loeb, known for his bold yet disciplined approach to extraterrestrial phenomena, has shared two pieces of information that could redefine how we understand this object. The first, a confirmed radio detection of hydroxyl, or OH, absorption by the Meerkat radio telescope in South Africa. The second, new post-perihelion images that reveal a complex network of jets extending from Atlas's surface, seen on the 8th of November 2025. For the first time, scientists have concrete proof that Atlas is not dormant. It's thermally active, releasing material as it interacts with solar radiation. That fact alone changes the conversation. A supposedly inert interstellar object is showing signs of dynamic, evolving behavior. But it's the nature times of that behavior that makes this discovery so provocative. According to Loeb's team, the Meerkat radio data captured distinct absorption lines associated with hydroxyl molecules, a chemical signature usually linked to ice sublimation or the breakup of water-bearing minerals. These lines are not emission, which would suggest heat and energy release. Instead, they're absorption, meaning there's a colder region of gas positioned between Atlas and a warmer radiation source in the background. In other words, the object is surrounded by a shell of cold gas material released and then chilled as it drifts away from its surface. Loeb points out that this is a strong indication that Atlas remains active long after perihelion, the point where it passed closest to the sunday. In fact, at the time of observation, Atlas was already receding from solar proximity, yet still showing measurable signs of molecular activity. The thermodynamics are consistent with an object that maintains a delicate balance between heating and cooling, like a self-regulating system responding to its environment. Meanwhile, optical telescopes on Earth captured something extraordinary. Stacked exposures taken on November 8 revealed a luminous halo surrounding Atlas, extending nearly 500,000 kilometers more than the distance between Earth and the Moon. And within that halo, at least 7 distinct jets of material. Some point outward, some toward the sun itself, starward jets that are rarely seen in natural comets. The complexity of these jets shocked even veteran astronomers. Under difficult viewing conditions, twilight skies, and bright moonlight, the structures persisted in every frame. Their symmetry, persistence, and pattern defied coincidence. If they were just random bursts of vaporizing ice, they wouldn't appear so structured. Avi Loeb interprets these features with characteristic caution. He presents two possibilities, and he insists that both remain valid. The first, a natural explanation. Localized patches of volatile ice on a comet-like nucleus, venting gas and dust when heated, producing the observed jets and anti-tails. The second, a technological hypothesis that these jets could, in principle, correspond to directional propulsion systems, perhaps for orientation or thrust correction. He is not claiming proof of technology, but he refuses to rule it out. Keep the technological hypothesis on the table, Loeb repeats. Let the data speak before we close any doors. At this stage, the key is transparency. Loeb's remarks repeatedly circle back to one frustrating issue: access to high-resolution data. The most detailed images of Atlas to date were captured by the HiRISE camera aboard NASA's Mars Reconnaissance Orbiter on the 23rd of October 2025 at an estimated resolution of 30 meters per pixel. Yet, Those images have not been released. Scientists have confirmed their existence, but they remain locked within institutional archives, unavailable to the public or even to the broader astronomical community. For Loeb, this lack of openness is unacceptable. In his view, data about an interstellar object, something not belonging to any nation, any planet, or even the solar system, should be freely shared. Science progresses at the speed of transparency, he says. Without these high-resolution images, researchers are forced to speculate instead of analyze. And speculation, he warns, fills the void that science should occupy. He has gone as far as publicly criticizing the institutions responsible for withholding data. Formal requests, he notes, have been filed, even letters from representatives of academic institutions and government offices. But the responses, when they come, are slow and inconsistent. Meanwhile, public engagement grows, millions follow updates online, while astronomers race to piece together what little information they have. Loeb's frustration is not just philosophical, it's practical. Every week that passes without new data limits the scientific window for coordinated observations. Atlas is on a hyperbolic trajectory. It's leaving the solar system. Once it's gone, there will be no second chances. The lack of shared information, he argues, prevents global teams from calibrating their instruments in time for meaningful follow-up. Beyond the immediate data concerns lies an even deeper mystery, the question of acceleration. Observations from multiple networks show that Atlas's motion deviates from the purely gravitational path predicted by models. The object exhibits a measurable non-gravitational acceleration, requiring extra terms to be added to its orbital equations. That means something is pushing it, but no one knows what. If that acceleration were caused by typical cometary outgassing, the laws of physics tell us that the object would need to eject roughly 1/16 of its total mass, around 5 billion tons of material, to generate the observed thrust. Such mass loss would produce a vast debris cloud easily detectable from Earth, but no such cloud has been observed. So what's left? Two possibilities remain. Either Atlas operates under a natural mechanism not yet understood, perhaps a form of radiative or magnetic propulsion beyond known cometary physics, or there's an artificial component producing thrust without ejecting large amounts of material. Both options stretch our understanding of astrophysics. Both demand evidence. For Loeb, the path forward is clear. He urges continuous, coordinated observation using every available asset from Earth-based radio arrays like Meerkat and FAST to space-based observatories like Juno, which will pass within 53 million kilometers of Atlas in March 2026. Juno's dipole antenna, sensitive to low frequencies between 50 Hz and 40 MHz, could detect signals or emissions impossible to see from Earth's surface. It would be, as Loeb describes, a once-in-a-lifetime opportunity to test whether an interstellar object can emit structured radio signals. The implications would be profound, either confirming complex plasma dynamics around a natural body or hinting at something else entirely. At this point in the investigation, one thing is certain. Atlas continues to defy expectations. It emits radio signatures, produces structured jets, accelerates in unexplained ways, and hides crucial details behind layers of institutional red tape. As Loeb summarized during his recent talk, we now have measurable signals, tangible data, and a window of time before this object disappears forever. The question is not whether Atlas is natural or artificial, not yet. The question is whether we'll gather enough evidence before it's too late. The story of Atlas is far from over. In fact, it's only just beginning. And in the months ahead, as the object drifts beyond Mars and approaches the orbit of Jupiter, the world will be watching, searching for answers in the dark. By mid-November 2025, the atmosphere within the scientific community surrounding 3I, Atlas, had shifted from curiosity to quiet tension. The data gathered from Meerkat and the post-perihelion images painted a picture that was both promising and unsettling. The object was not behaving like any ordinary comet or asteroid. It seemed to be governed by rules that straddle the line between the natural and the engineered. Avi Loeb's calm, deliberate voice during interviews contrasted with the implications of what he was presenting. The signals are real, he said. They are consistent with molecules being released at predictable temperatures for an object at that distance from the Sunday. His words echoed across international forums, sparking debate in observatories, classrooms, and online discussion boards. The Meerkat data, once verified, became a milestone. Absorption signals of hydroxyl were narrow, distinct, and perfectly aligned with the Doppler shift expected from Atlas's velocity relative to Earth. It was the kind of evidence that left little room for observational error. The gas was cold, but it was undeniably there. That meant active chemistry, not a frozen relic drifting silently through space, but a body interacting with its environment. Yet the details of that interaction deepened the mystery. The width of the absorption lines matched what one would expect if Atlas's surface maintained a precise equilibrium temperature. Too exact to be random, too stable for a chaotic object exposed to the violence of the Sunday. It was as if the entire surface operated like a controlled system, shedding and retaining material with remarkable balance. When stacked optical images from November 8 were released, they only magnified the intrigue. The halo surrounding Atlas glowed faintly bluish, spreading 500,000 kilometers into space, with 7 discernible jets cutting through the haze. The orientation of those jets was the puzzle. Several were directed toward the sun, a geometry nearly impossible under standard solar heating models. Normally, cometary jets push away from the sun as volatile ices sublimate on the sunlit side. Atlas defied that logic. Observers confirmed that these were not photographic artifacts or reflections. The images had been taken under bright conditions with moonlight and atmospheric interference. Despite those obstacles, the jets remained visible, frame after frame. The persistence of the pattern ruled out coincidence. Something systematic was at play. Loeb's hypothesis that these jets might correspond to localized propulsion was met with skepticism, even mockery, in some academic circles. But others saw value in his caution. "We must not let the weight of precedent blind us," he said. "Every discovery begins as an anomaly." His words resonated because the data demanded attention. As debates continued, Loeb turned his focus toward the upcoming opportunity in March 2026, when Atlas would pass within 53 million kilometers of Jupiter. The Juno spacecraft, orbiting the giant planet, could offer an unprecedented angle. Its dipole antenna, designed for studying Jupiter's magnetosphere, was perfectly suited to scan for low-frequency radio emissions. If Atlas emitted even a faint structured signal, Juno might detect it. Loeb called this the cleanest experiment we can run before the object leaves our reach. Meanwhile, the controversy over the withheld high-rise images grew louder. The scientific world knew the Mars Reconnaissance Orbiter had captured frames of Atlas on October 23, just days before its perihelion. At roughly 30 meters per pixel, those images could resolve features on the scale of large buildings, the clearest look humanity had ever had at an interstellar visitor. Yet they remained unreleased. Loeb's frustration was palpable. "The universe does not wait for bureaucracy," he said during an interview. "Every delay is a lost opportunity for understanding." He wasn't alone. Petitions emerged from universities and citizen science organizations demanding transparency. Hashtags like #ReleaseTheHighRise trended for days, a rare moment where astrophysics pierced the mainstream conversation. Behind the politics, the science advanced quietly. Teams analyzing orbital models confirmed that Atlas's trajectory showed clear, non-gravitational acceleration. The magnitude was small but consistent, an outward push that varied slightly with solar distance, yet showed no evidence of chaotic venting or fragmentation. If the cause were outgassing, there should have been detectable debris or at least a measurable tail. Instead, telescopes across Chile, Spain, and Hawaii saw only a faint, clean halo. Momentum conservation demanded mass loss to explain the acceleration, roughly 5 billion tons, if the standard model held true. But no such loss was seen. This left theorists struggling for explanations. Some proposed asymmetric radiation pressure due to reflective materials. Others suggested magnetic coupling with the solar wind. But all models required assumptions that stretched known physics. To the public, Atlas became a symbol, a cosmic riddle that no one could fully solve. News outlets framed it as the quiet engine from the stars. Documentaries began production. Loeb, ever the careful scientist, avoided sensationalism. "We must gather data, not myths," he said, though he acknowledged that myths were born precisely when knowledge was withheld. In December, as Atlas moved beyond the orbit of Mars, its brightness fluctuated unpredictably. Some nights, it appeared half a magnitude brighter. On others, it dimmed as though its jets had shut off. Spectroscopic readings hinted at subtle color changes, a shift toward blue wavelengths, suggesting either fresh ice exposure or compositional transformation. Every clue raised more questions. The upcoming weeks promised clarity, but also pressure. Loeb urged international coordination. Over 200 observatories had already committed to tracking ATLAS through December and into early 2026. "This is not a single nation's discovery," he said. "This is a test of our species' curiosity." At the same time, whispers began to circulate about other potential detections, low-frequency fluctuations picked up by amateur radio astronomers in late October, coinciding with the Meerkat event. Nothing conclusive, but enough to keep enthusiasts listening. The media framed the debate as two competing visions. On one side, the traditionalists, astronomers, who saw Atlas as a complex but natural interstellar comet, its oddities explainable by extreme conditions and observational bias. On the other, a small but growing group open to the possibility that Atlas represented something more, a probe, a fragment, or a remnant of technology older than the solar system itself. Loeb stood somewhere between. He never claimed evidence of technology, but he refused to dismiss it prematurely. "To explore the unknown, we must allow for the unknown," he wrote in a Harvard commentary published mid-November. Science does not fear speculation. It fears silence. The line captured the essence of the debate. Atlas was both a mystery of matter and a mirror for human imagination, reflecting our hunger to know whether we are alone or simply late to a cosmic conversation that began long before us. By the end of November, Loeb summarized the situation succinctly. "We have detection, we have acceleration, we have jets. What we lack are explanations." The next phase of observation would either expose the truth or deepen the enigma. And as Earth rotated beneath its silent visitor, one fact grew clear. 3I Atlas was not finished surprising us. As December 2025 approached, the story of 3I Atlas became impossible to ignore. It had transcended the boundaries of scientific discourse and entered the public imagination. Every new update, every spectrum, every image, every unexplained fluctuation was dissected and debated by professionals and amateurs alike. Yet beneath the noise, the data remained consistent. Atlas was accelerating without an apparent cause, emitting jets that did not fit natural models, and showing signs of controlled or patterned activity. The universe was whispering, and humanity was trying to understand the language. Avi Loeb continued to lead the discussion, alternating between measured analysis and a deep sense of urgency. His focus remained on evidence, not speculation. If there's one thing we've learned, he said during a November 28 interview, is that the universe is capable of more than our equations can predict. That sentiment defined the tone of the investigation moving forward. The next big step was coordination. Over 200 observatories, both professional and amateur, had agreed to monitor Atlas as it approached its closest point to Earth on the 19th of December 2025. It wouldn't be a close pass by cosmic standards, about 270 million kilometers, but it would offer the clearest window for synchronized observations before the object began its long exit from the solar system. For many, it was a final chance to capture the data that might settle one of the most perplexing mysteries of the decade. Meanwhile, the call for transparency had grown into a movement. Scientists and citizens demanded the release of the Mars Reconnaissance Orbiter's high-rise images, the ones taken just before Atlas disappeared behind the sun in late October. If they were as sharp as expected, 30 meters per pixel, they might reveal whether the jets were naturally aligned, fractures, or something more geometric. Days turned to weeks, and still no release. Some claimed the data was being withheld for security review. Others whispered of internal disputes between NASA divisions. Loeb avoided the politics but made his frustration clear. We cannot investigate interstellar phenomena with a culture of secrecy, he said during a press event. This is not a national matter. This is a universal one. His words drew applause and criticism. For some, his insistence on the technological hypothesis was seen as provocative. For others, it was simply the scientific method in its purest form. Follow the evidence, no matter where it leads. By early December, Meerkat had resumed targeted scans of the region where Atlas was expected to reappear. The hydroxyl absorption lines remained detectable, but weaker, perhaps due to distance, perhaps because the object's surface had stabilized. The pattern, however, remained too consistent to ignore. The same frequencies, the same Doppler shift, the same thermal profile, cold gas, steady release, equilibrium maintained. It was as if Atlas was alive, maintaining balance in its internal systems as it traveled farther from the Sunday. Then came a new observation, small but extraordinary. Several telescopes reported a faint polarization anomaly in reflected light from Atlas. Instead of scattering randomly, like typical comet dust, the reflected light exhibited strong negative polarization, suggesting an unusually smooth or conductive surface. Metals, perhaps. Iron, nickel, or even exotic alloys. The data aligned eerily well with Loeb's earlier claims. A metallic composition inconsistent with ordinary comets. If true, it added another layer to the mystery. A metallic body accelerating in non-gravitational ways, emitting structured jets, and maintaining cold gas envelopes, it no longer resembled a comet at all. It resembled something designed. Despite the mounting tension, Loeb remained cautious. Anomalies don't prove intelligence, he reminded his audience, but they do prove ignorance. We don't yet know what we're seeing. His team continued to analyze every frame, every signal, preparing for the moment when Juno would enter position near Jupiter. March 2026 was circled on every calendar. The spacecraft's instruments, designed for planetary study, might instead become humanity's first interstellar communication tools. While scientists worked, the world watched. Online communities speculated wildly, some imagining alien probes, others claiming government cover-ups. Yet through it all, the actual data told a subtler story. The universe is more complex than we imagine. The December sky brought new opportunities. Atlas had brightened slightly, its halo stretching thinner but broader. Its jets appeared stable, each pointing in a near-fixed orientation as though aligned with invisible coordinates. Observers noted that the orientation matched small but precise deviations in its orbital vector. It was as if the jets were correcting its path, not randomly, but with intent. In a final December report, Loeb's group summarized the findings. The radio detection of hydroxyl confirmed that Atlas was thermally active. The multi-jet structure revealed dynamic behavior inconsistent with standard cometary models. The non-gravitational acceleration persisted, but without measurable mass loss. And the lack of debris clouds, combined with the metallic spectral hints, left a gap no conventional theory could fill. Still, Loeb refused to cross the line into assumption. Whether it's a comet, a craft, or something in between, we must let data decide, he said. The universe has no obligation to make sense to us. Our job is to make sense of it. The investigation had now become something larger than science. It was a test of humility. Humanity was staring at an object that could rewrite the story of interstellar exploration, and we weren't sure whether to classify it as a comet, a relic, or a message. The idea that something could travel across the stars, powered by unknown mechanisms, and remain intact after brushing past the sun was no longer fiction, it was observation. On the 19th of December 2025, the day of closest approach, telescopes across the world turned toward the faint glimmer of Atlas. From Chile to Japan, from the Atacama Desert to the peaks of Hawaii, they watched as the object drifted silently across the night sky. The data streamed in. No explosions, no tail eruption, no sudden fade. Just steady light, unwavering motion, and a pulse of radio absorption matching the same frequencies as before. It was, as Loeb later described, the quietest signal of significance I've ever seen. By the end of the year, as the object moved outward toward Jupiter, the story reached a quiet pause. No definitive discovery, no final revelation, only the persistence of questions. The unanswered mystery became its own message. Perhaps, Loeb suggested, the meaning of Atlas was not in what it revealed, but in what it forced humanity to confront, the limits of certainty. He closed his final statement of the year with a reflection that resonated far beyond astronomy. We stand on a small planet orbiting an ordinary star, yet we dare to measure the motions of objects that came from the stars themselves. Whether Atlas is a rock or a relic, it reminds us that the universe is not empty. It is alive with stories we have yet to read. And so the investigation continued through December, into the new year, and toward the approaching rendezvous with Jupiter. Somewhere out there, 3I, Atlas, moves silently through the darkness, leaving behind only the faint traces of its presence. A whisper of gas, a glimmer of light, and a question that refused to fade.